Friends, it's Jordy here, and welcome back to my YouTube series about things you can do in RStudio, which may help you in your research projects, in your studies, in business, in life. And last video was pretty long, in which we did box plots. And box plots are very useful, as we remember, to plot raw data, because they can show lots of information, such as medians, interquartile ranges, outliers. For raw data plotting, I'm normally using box plots and scatter plots. And for averages and standard deviations, I normally create a separate data frame, a summary data frame, which we did before and we will do again today. And that is what I plot, using the standard deviations as error bars above and below the geom bars. And both raw data and means and summary data can be really, really useful. Sometimes you can show both in your papers. What I'd like to do is something that will be much shorter, and that's make a pie chart. And pie charts are great for showing like percentages of rows or counts within a certain response variable. And this is an example of what a pie chart might look like. Okay, it's like a pizza, right? With the different sections being the different levels of the grouping variable. And if you Google pie charts online, you might find some people hating on pie charts. And I think that's a shame, because pie charts can be pretty useful, like I said, for counts. So let's work today to show how a pie chart can be made with the diamonds data frame. And we did look at diamonds before, didn't we? And diamonds data frame is a large data frame, 54,000 rows, which contains information about diamonds. The main response variable being the price column, okay, and everything else being information about individual diamonds. Googling this would find out, where it comes from, whether it's information from a particular shop or in general, or a certain year. We don't know that information from this, but imagine it's information from a shop. And these are all the diamonds that it has on stock. To make a pie chart, we could probably go ahead and try this with this data frame, but I'm going to filter it, because my old computer would have problems processing 54,000 rows. The new one might be okay, but if you do have an old computer, this could cause a problem, for it. So let's not do that. Let's remind ourselves of how to filter. This would be something you'd want to note, okay? That we are going to filter the data frame to reduce its size. Let's only show one clarity. Let's say SI2, and let's show one cut, which is ideal. That means we can apply a double filter, and I think last time we just did a single filter, but you can use dplyr to create a double filter as well. My new data frame is going to be called diamonds filtered. It's going to be based on diamonds. I always like to think of this syntax as, the back arrow points towards a new thing and away from the old thing. Pipe function, the cleaning function, and the code for filtering, as you remember, is just this: filter, the name of your first thing that you're trying to filter, followed by 2 equal signs. And the 2 equal signs is important. It won't work without the double equals. Let's take choose what we want our filter to be for the cut column. That's going to be ideal. And if we were to run it now, okay, let's find out how many rows we're left with after that single filter. Then after that, we'll filter again for something else. Okay, so you see, we're looking, we can see this result in the console. We're looking at about 21,500 rows there. Let's add a plus sign. Okay, the and sign. It's not a plus sign, it's an and sign. Okay, which is this one here. On my keyboard, it's like the number 7 button. And we're going to add clarity here. Again, 2 equal signs are important. And then we put our second term that we're filtering by. Let me view this as a data frame now. And the goal is to kind of reduce that 50,000 down substantially. Let's see. Now we've got 2,598 rows. Okay, which is great. And that's great for almost anybody's computer, I believe. If you were to present this, be sure to leave a caption under any graphs or any text associated with our results here. That this has been filtered substantially. Okay, now we're going to create a summary data frame. So let me leave hashtags and we'll keep this organized. Summary df. And this summary data frame is going to hopefully tell us the counts of a specific column. Okay, now unfortunately we can't use cut anymore and we can't use clarity because those are gonna be all the counts in those columns, ideal and SI2. That only really leaves us with one column that makes sense to count, and that's the clarity column. As a reminder, if you check, for example, the str function, the things you generally count will be factors. So they're going to be factors or potentially CHR, which are characters. You wouldn't really want to count the numbers. In this case, you definitely wouldn't because these are decimals. I mean, you could potentially do table because it looks like there's not that many levels in the table column. But things like this, x, 3.95, 4.35, 4.31, each of those might only actually occur once. What makes sense is to choose a column that's definitely got repeated values. And the color column is your kind of prime example here of one that does. And it's an ordinal factor. So let's use dplyr again to do something else. It's going to be, I'll take the code from before and change it. It's going to be using group by and summarize. So I'm going to call this diamonds filtered summary. It's based on this one, the previous one. But this already has a filter brought into it. And that's another nice thing about dplyr, ggplot, is copy paste. Copy paste as much as you like until you remember it off by heart, which at this point I kind of do because I've been doing it long enough. But if you're a beginner, feel free to copy paste. We're going to group by, and the group by column is going to be, in this case, the color. It starts to suggest it here. So this is, of course, the column that we want to get counts for. Counts for. Think of that as an X on a graph, typically on a scatter plot or on a bar chart. And then we do want to go onto the next line and summarize, okay? Now for the purpose of counts, we only really need one thing in our summarize line, and that's a counts column. You can call this whatever you like, but most people call it number, n, or counts. And this code is very simple. We've used summarize before to calculate means and standard deviations. Like I said, that would go into a bar chart. That's where you would add extra stuff to this line. But for the purpose of what we're doing for a pie chart, you don't need to. Okay, so we're going to put this here and view it. Great, so now we've got a new data frame that has counts of the different colors, D to J, within that filter that we wrote, SI2's ideals. And this is something that we could put on many different types of graphs. We could put this in a scatter plot if we wanted, or in a bar chart. It's probably a good start to put it into a bar chart. And the reason why is because pie charts and bar charts use much of the same code. In fact, a pie chart kind of is a bar chart turned into a circle. So that's what we would want to plot, the counts as the different pieces that make up to 100% of the pie. Okay, let's do a bar chart first. And what is important about this stuff is you leave the X blank, and you'll see what I mean in a second. Data equals diamonds filtered summary. Then your AES. X equals this. Okay, and this would be a little bit like using stat equals counts in a bar chart. Most of the stuff we've done before, when we've used stat equals identity, we have an X and we have a Y, and we just want to show one against the other. Here we don't need that, okay? So then you're going to say Y equals the response column, that's the counts column in this case, and fill equals, that's going to be the group by column, okay? So as I said before, I wanted to clarify this. You know, group by in a normal, typical chart, which is your bar chart with identity or your scatter plot, will be X. But in this case, the group by is the fill in a bar chart, with in a pie chart where you don't have any X. And we've got our first line sorted, and now we're going to make the graph type. And as I said, we'll start with a geom bar and progress from there. Geom underscore bar. Now you do need a stat in here. Stat equals identity, but it's an identity without the X, which will turn these into different sections, add up to 100%. So let's see. Okay, good. Now you've got this. This is all the counts, the Y. X is nothing because it's a single stack, okay? And the colors are represented here. Blue, dark blue being D, and J being yellow. And you can kind of see from this that a lot of the colors have the same numbers of rows. This is counts of rows. In fact, let's add stuff like that in, you know, just to keep things nice and clear. Counts of diamonds, X equals nothing, and fill, if you wanted to, you could add fill here. That will change this word to whatever you want it to be, and we can put a capital. And so the fill is for legends there. So we're going to run this again and see the updates. We've got this stack of the counts of diamonds. Color has been turned to a capital C. The sections, with the exception of J, are very similar in size. And now what we can do is easily turn this into a pie chart. And to do that, you just need something like this. You know, coord. You're going to go through this list and you're going to see what the different options are. Coord polar is the one we want. Okay, plus coord polar, you just put this Y, okay, in quotation marks. And that is this important column here, which makes up the stack. That's going to be turned into a circle now. So we take that and we just turn these into smalls. So now what we've got is this bar chart has been turned into a pie chart. I don't think that there is a geom underscore pie. No, there's not. There will be very soon, I guess. But now we do it through this method using a bar chart. What can we do to make this graph look a little nicer? Let's do a theme underscore void. Theme underscore void here because it's got rid of a lot of superficial information which actually isn't necessary to understand the graph. And I want to just kind of like reiterate that I find these graphs pretty useful for general purposes, like in first few slides of a presentation to summarize how many rows you have from different stations, different countries, different groups of society. For a graph that most people will be able to understand just by looking at, because they can relate to it quite easily without having too much information on it. And so we've simplified this, and we've made it as clear as we possibly can, using capital letters and not needing to show the Y label anymore, which we don't really need, okay? If you have a caption, for example. Let's put theme code in here, and I'm going to come back to theme code in another session. So useful for legends and for other things. General appearance of the x-axis, the y-axis, if you have it. Legend position equals, we can choose where we want our legend to go, and I like using top position, so it puts it like here for these kind of graphs, but it's up to you. You can put it left if you like, or you can put it at the bottom. So the bottom would look like this, and these are just words that are part of the code. Finally, now let's add a code line which adds the counts of the different sections onto the graph. And that would be really useful, I think, in this case for separating the different blues, okay, and the greens, which all seem to be similar in size. So for this one, it's geom_text. We did this before with geom_text repel, text_repel. That's part of ggRepel library. Both will work. Here we just need another AES, and AES is always about columns, okay? So you notice every time I use it is where you've got like an X or a Y or something, or a label that's actually a column. Here it's AES label equals, and we do, in this case, the counts, okay? Counts. Let's see what happens if we run that now, because it's almost good to go. All right. It put them on, but R did not know where to put them. It didn't know where to put the counts, and it's not associating the counts with any particular sections that they're supposed to be associated with, which is very unuseful. And so for that, we need to really guide it by using something called position equals position_stack. This is a little bit like position_dodge in a bar chart. I think we did that before for moving bars next to each other instead of on that single stack that we saw a minute ago. Then you do vjust in the orange brackets equals, for the purpose of a pie chart, it's 0.5. I guess it kind of makes sense, in terms of the circular shape of it. And what it does now is puts the counts into the right places, so they fit where they should be. And we've confirmed now, look, the blues all have similar counts. Yellow is much less, 110. Pretty useful, easy thing to do. You make a bar chart but don't have an X, or put it in quotation marks. It needs to be there actually, but it needs to be in quotation marks. If you tried it without this, it might not work. So I'm just gonna delete this and try it and see what happens. Yeah, it doesn't work. So you need to have X equals quotation marks. The chord polar turns a stacked bar chart into a pie chart, and everything else we did was just aesthetic stuff. I hope that helped. Next video will actually be pretty long, I think, or part of a longer few videos in which I show R Markdown and how to take stuff in a script, because I normally do it that way, copy paste it into chunks in R Markdown, and that R Markdown can be a report that you submit. See you next time, and have a great day. Good luck coding.